The previous tutorial can be found in the description, where we created a character that moves in 2D. Slice has a dash mechanic for moving around the level and avoiding spikes, which is what we'll be adding next. One of the main things in this in the Slice game is the kind of dash through the air, and that's based on the stick. So you push a direction with the left stick and press, we'll just make it square, you can make it whatever you want of course, and then it will dash in that direction. So I'm going to have a chip for that to hold all of our stuff, and we'll add a node and a wire in the left stick into there, like that. So let's just test to see what kind of numbers and stuff we're getting from that. So this is a colourful wire. It doesn't just have one colour, it has two colours. That's because it's kind of braided together more than one value. If we put it into a splitter, we can see what those values are. And that's an X and a Y, so left and right and up and down. So let's just find out what those values are with some displayers. So the top one is left and right, and the bottom one is up and down. So when I'm pushing right, that's positive, left it's negative, and then up and down, yeah, they seem to work okay actually. So we'll just use those. So that will give us like a direction. So if I demonstrate what I mean by a direction, I usually use a cube for this with a mover on it, because that has a direction associated with it. It has this arrow, and we can actually wire something into the direction to tell it what direction to move in. So if you wire that in there, make sure it's the plug thing with L1 and X. You can have these different modes. Make sure it's the plug, and that will just set the direction. So now we need to, let's put this in the background, get a test mode, and we need it to be, it's like wandering off, we need it to just not move. Cool. So as I push different directions with the left stick, it's pointing in different directions. And Y seems to be flipped for some reason, so we'll just take that into account. But we'll use this, you will use a mover on the puppet to shove us in that direction when we do a dash. So first let's just fix that direction. I want to split this and then mess with the value, so we're going to mess with Y, multiply it by -1. We will recombine it into a new direction value, which will be a 3D value. So we put a combiner, which is like the opposite of a splitter. It makes one of these fat wires, and we set it to 3 numbers mode, and then we just wire stuff in. This is a 3 number kind of generalized kind of fat wire. It's not a left stick, right stick type of deal with X and Y. It's just 3 numbers, so it could represent any number of things. As long as there's 3 of them. Yeah, so it just labels them as A, B, and C, and those correspond to X, Y, and Z for the for like the 3D coordinates or directions and things. So we've got the Y into the Y, which is the second one, and the X into the X, which is the first one. And we don't want any Z, which would be the kind of depth into the scene. We just want it to be kind of 2D. So we'll remove that wire and wire that new version into it, and try that again. So pushing up and up, top left, top right, right, down. So that's all working fine. And now we've got a mover that will move an object in that direction that we're pushing the stick in. So let's drag the mover over into here. Press triangle on that because we just want it to affect the puppet. If you press triangle on a gizmo, it resets. So it'll use like the center of mass of the thing it's on or whatever, and that's like works for any setting. And because it's in this chip, and this chip is in a chip, and that chip is kind of linked to the puppet, then any gadgets in here will affect the whole puppet. But when do we want that to happen? So first let's delete those. And so we remember what this is, we'll edit this node, we'll just tweak it as any gadget, and we'll give it an icon and give it a name, and we'll give it a color, and it's like from the controller sensor, so we'll make it green. Now we'll have another node, and this will be when we want this dash to happen. So we'll give it a kind of pulsing instant thing happening. Cool. So we'll use square. We don't care if we hold square. We want to know when we go from not pressing square to pressing square down, and that's called a pulse. So if we get a signal manipulator and wire square into there, then we'll use pulse on input on. So when it goes from off to on, when we're not holding the button to holding the button, it will send a pulse, which is a really brief signal. So it's like a trigger to do something, as opposed to the player is still holding square. We don't care about. So let's put that into there. We'll actually keep it on for like a second or something. I think that's roughly how the game works. So I'm going to use a timeline. I'll open the timeline and we'll just put the mover in here for now, and just make it last the length that we want it to last. That's fine. And we'll put it onto once mode. So we'll leave it on sustain, and we'll see how that works. And then put the button into there, and we'll pin that to the screen and scale it up. I just grabbed it with R2, and I'm scaling up with the D-pad. And now we'll go into test mode, so I can play around and we can see the timeline. So when I press square, it flashes but doesn't really do anything. And you can just about see the playhead very slowly move along each time I tap the square button. But we want it to play all the way through every time I tap the square button. So we'll tweak the timeline and say once mode. That means that every time the timeline goes from off to on, it will rewind back to the start, and it will play all the way to the end. Even if it loses power halfway through, it always makes sure it gets to the end. So now if we test and press square, it goes all the way to the end, and I just tap square and it goes to the end. So but we've got this set to no speed, so we'll give it some speed, full movement strength, and probably damping as well. And let's try that. So I'll just tap square, so it drags us in the direction. So I didn't hold as a direction, so it's pulling us to the right. But if I hold up, it's pushing us up for that duration. And top left, and top right. Cool. So if I push up and then I let go, it starts moving right, which is kind of like the default direction sort of thing. We want to kind of lock in the direction we're going when we press square, and then it just stays locked in until we stop, the dash ends. So for that, we'll have another signal manipulator. These are very useful. So this is processing and figuring out the direction. Then we want to do some stuff with it. So let's wire that in there. For now, we'll just put it into remote controllable mode, and that will mean we can play time and just push the stick and see the readout. If I'm pushing up, then some of the bar goes up like that on the face of this gadget. This is the input side, and that's the output side. So normally they're just the same, unless you do some other stuff in here. So if I'm pushing up, the bars go up. If I push up, and while I'm pushing up, I press freeze and turn that on, and then let go of the stick, then the input goes down because now I'm not pushing up anymore, but the output is locked in because it's just frozen that output. So we want to freeze the output of this. We'll have the direction go in, and it will be coming out all the time, but then we'll freeze it while we're dashing, so that the direction doesn't change that comes out of here. And then instead of using this version, we'll use this frozen version like that. So in the timeline, as well as powering this mover, we want it to freeze this signal manipulator when we're using a keyframe to do that. And then we can just make this longer on the timeline, and I'm just scaling that up. You can drag the edges. So that's freezing direction. Cool, during the same time. Nice. So now I'll put this back to the possessable mode and play time, and it auto possesses. So now I'll hold up and press square and it goes up. And if I let go of it halfway through, so up and then let go, it's still locked in. And I'll try pushing in different directions as well. So up, and I'll push in different directions. And it is being affected left and right. You can see it's going a bit left and right when I'm doing that. That's because it has this high air control. So while it's in the air, it still is able to move around. You're able to direct it. So we kind of want none of this to work while we're dashing. None of the controls or anything. And the default controls actually go into this puppet interface. So you've got like the left stick going into walk, which is also the run. So this is telling the puppet to walk in that direction. And you've got the gyro sensor going into the lean. So that's when you can tilt the controller to make the head tilt. And then X going into jump. So you want none of that to work. So I'm going to just, for clarity, you could do this with the same keyframe, but just so it's clear, I'm going to use a new keyframe and turn off that puppet interface. And now none of those default actions work anymore. But the controller sensor still works just fine. Nice, and I'll just zoom in here, make sure they're the same length. Okay. So let's try again. So square, and pushing in different directions isn't doing anything at all. So I go straight up and then push left, and nothing happens until after the dash. So I think that's fine.